So now that we know the difference between a function and a relation, we'll come back and we'll talk about function notation. When we see function notation written down on the border in our book, it looks something very similar to this. Okay, now, in the past, when we see two things touching and one's wrapped in parentheses especially, we take that to mean multiplication. However, function notation does not mean some number f times some number x. Okay, the whole piece together is all one notation. And when we read this out loud, we read it f of x. Now, the letter out in front, the f in this case, that's the name of our function. And the name of our function is really the least important part. I can name my function f, and yours can be g, and Paul's can be p, and Tom's can be t, and they can all be the same function. But the function does have to have a name. Here in parentheses, the x, this is our independent variable. The way that we've defined our function in the last video was that they're functions of x, but this can be a different variable. You can have a function of time and you can let that be t. You could have a function of p. You can have a function of y. But if we're talking vertical line test and that sort of thing, we're going to be specifically saying x is our independent variable. The independent variable is our input variable. Okay, that's the one that I plug in. The important thing to keep in mind when we're dealing with function notation is that f of x is just another name for y. F of x is just another name for y. So x's go into the function does its work, and the y's come out. There's our ordered pairs. And again, there can be no ambiguity. When I plug in one number for x, only one number for y can come out of that. When we're asked to evaluate functions, sometimes our function will be given to us as an expression in x. It'll say f of x equals 3x squared minus 2. And then once we know what f does to x, we'll usually be asked to find f evaluated at a certain point. So if I know f of x equals 3x squared minus 2, then if I'm asked to find f of 1, that means I go back to the expression I was just given, and every place there's an x, I'm going to put, in this case, a 1 instead. Now, when we're doing this arithmetic, remember the 2 is only hooked onto the 1. It is not hooked onto anything else because there's no grouping symbols. So 1 squared is 1. 1 times 3 is 3. 3 minus 2 happens to also be 1. Okay, f of 1 is equal to 1. If we're asked to find f of negative 5, that means go to your expression, and every place there's an x, I'm going to replace it with negative 5. And if I'm squaring the negative 5, that turns into positive 25. 25 times 3 is 75. 75 minus 2 is 73. If I'm given my function f of x as an expression in x like we are given right here, then if I'm asked to find f of anything else, I go back to that expression and I replace the x with whatever I was asked to replace it with. So maybe instead of f of 1 or f of negative 5, I'm asked to find f of p. That means I come up here to this expression, and every place there's an x, I'm going to replace the x with a p. Now, of course, I can't do anything more than this because I don't know anything about p, and these guys aren't like terms, and so I would just have to say f of p equals 3p squared minus 2. So when we were looking earlier at this relation, we said, oops, that's not a function. In fact, actually, I'm just going to go backwards through my slides that I already have. And so we'll say this one is a function. So let's call this function g of x, so we don't get it confused with what we had on the other page. And so maybe I'm asked to find g of -2. We said when we have a function, the x value is what goes in. That's our input variable. Okay, our input value. G is going to do whatever it's supposed to do to that x value, and it's going to spit out the y. Okay, so the question that this is asking, and we do not have to know what the equation is for this function right here. We can do this from the picture. It says when I plug in -2 for x, what y value comes out? So if I come over to my graph and I come left to x equals -2, I'm going to slide that out of the way. Maybe I'm going to go yellow. X equals -2. Then I'm going to go up or down on my graph until I get to the point on my graph that has the x value of -2. And then I'm going to go over here to the right and see what y value comes out. And I just drew over the top of my 4, but the y value that goes along with x equals -2 is a y value of +4. Maybe I'm asked to find g of -4. That means I'm going to go to the left until I get to -4. I'm going to go up or down until I get to the blue graph, and so I don't have to move anywhere because I'm already on the blue graph. And then my answer here is whatever y value I'm standing on. Okay, so since I haven't moved any steps up or any steps down, I say, well, the y coordinate right there on my yellow dot, the y coordinate is 0. Maybe I'm asked to find g of 1. Think for a minute at your desk what g of 1 would be. If I go to the right one step, and then I find the point on my graph, it looks like I'm right there. If I count, it looks like the y value is -5. So x's go in, the y values come out, and we can look at a graph and evaluate functions that way. Okay, that one was not a function, that one was not a function. Up here in the top left corner, let's call that function h of x. We said it is a function. So if I'm asked to find h of 2, that means when 2 goes into my function, what y value comes out? So from my list, I look and say, well, when x equals 2, it looks like y is equal to 3. So what about when x equals 1? Or what about when x equals 0? When x equals 1, 1 goes in, it looks like 4 comes out. When I'm looking at h, 0 goes in and 5 comes out. Alright, so let me find this mysterious thing I've been talking about, or passing by in my video. If we look at this graph right here, if we hop back and try to connect some things together, we earlier were asking questions like, is this a function? Okay. If I draw or think about drawing vertical lines through this graph, no matter where I slide them, they are not going to pass through more than one time. So yes, this is a function. If we want the domain of this function, it looks like the left end of my graph is 0. I'm going to touch everything from 0 up to 100. For the range, the lowest point on my graph also looks like it is a 0. Here's my 0, 0 right here. And the highest point on my graph looks like it lines up with 3000. So this is, instead of being a function of x, it says it's a function of t. I'm going to go ahead and change them to x's just so they match up with what we've been saying, but it's fine to leave them as t's if you're comfortable talking about this being a function of t. So since this is a function, we can evaluate it at different points. I can ask you to tell me the y value for any x that I want to pick between 0 and 100, including both those values. So when x equals 0, on my graph, there's my x equals 0, I want to know what the y value is. And it looks like the y value is also 0. I would like for you to find me g of 25, g of 50, g of 75, g of 100, and then maybe g of 37 while you're there. Okay, pause the video and see, write down as much as you can, and then turn it back on to see the answers. So when x equals 25, we go up to the graph, and it looks like the y value there is, I'm going to get my box to move, is 3,000. If I come over here to x equals 50 and go up, it looks like my height is still 3,000 there. But if I come over to 75 for x, now my y value is only 2,000. And when x is 100, I still see a 2,000. Now, if we didn't have the equation for this, okay, or if this was a different setup, I mean, if I asked you to find g of 10, that might be kind of tricky. We would have to just give an estimate. But because my graph is flat for all of the values between 25 and 50, all of those are still equal to 3,000, then we would say g of 37 is equal to 3,000. Okay, same if I asked for g of 95, I would say, well, I'm still at 2,000 there. Any number I want to pick between 75 and 100 is going to spit out 2,000 gallons. If you have questions about evaluating functions, we can find the y values from looking at a graph. We can find them from looking at a list. If I can get back to my list, there it is. Okay, or from, if we're given an expression, well, it's hard to say. If we're given an expression in x, we can just plug in. So give me a shout if you have questions.